All right, there we are. I'm Jason again. Gonna go for another project, networking project. This one we're gonna be introduced to OSPF, which stands for Open Shortest Path First, but it gets into dynamic routing as opposed to our last project, which was static. So first thing we gotta do is take a look at our network. Everything here, we're dealing now with 5 routers, and as we can see, they're all on the same 192.168 network, and it looks as though this one right here has something shut down, so the path is not open here, and they're all /24 subnet mask. So first thing it wants us to do is remove static routes and also make sure everything is open. So we're going to go on into router 1 here. Go ahead and enable, do a show run so we can see what might be going on. Everything on this one looks good, but there are multiple static routes set up. So we're going to go in, configure terminal here so that we can remove those. So we're going to do our no static route. So no, and we're just going to do some copy and paste here. No IP route 192.168.20.0. That takes care of that. So we're just going to repeat. Keep going down our list here. Just some copy and paste, which will get rid of these static routes. Because static routes have a shorter administrative distance, which means if a static route is active, the router will be, everything will take the static route before it looks at doing OSPF. So you have to remove them in order for OSPF to fully function. So that's got that router taken care of. Moving on over to router 2 here. Enable, show run, and everything should be up already. There are, looks like 2 static routes to remove on this one. So just continue the same process and just working our way around. Okay, that's got that one taken care of. Let's get back out. Move on over to our 3rd router. And just as always, show run to get an idea of what's going on here. Looks like the interfaces are in good standing, and we got 3 static routes that need to be removed. So config term, configure terminal, do a copy, no IP route, and repeat the process a few more times here. All right, that one is taken care of. Moving right along, we got 2 more routers to go. So All right. Now moving up to our final router, which I'm assuming has an interface that is down that we probably need to bring up to start. So let's hit our show run and look a little more closer into that. So there's our first interface, which has a shutdown command. So we need to go into Gigabit Ethernet 000 and do a no shutdown. All right, so let's config term. Then we're going to go into interface Gigabit 000. Do a no shut down. And as you can see, Packet Tracer does have your visuals, which puts both of those in an up state. We're going to get back out of that, go right back into a show run so I can take a look and see if this has any static routes. It does. It has 2. So we will remove these last 2. Static routes so that we can start setting up Ospf. There we go. So now everything is set up. I'm going to go back around, just kind of move over here to the first router. It has router IDs labeled that it wants us to go ahead and set up. That's what Ospf and other protocols are going to use to identify each router. Otherwise, it will use an IP address on one of the interfaces. I believe the highest IP address. So let's go into router 1 here. All right, so config term again. Now right here, we are going to do router Ospf, and we're going to identify it as Ospf 1. Hit our enter and go into our new mode, and we're going to go ahead and give it that router ID. So we're going to do router ID, and we're just going to use what's labeled here. So this one, 1.1.1.1. There we go. Now to set up Ospf, you're going to go network. Now you want to do your network IP, which as you can see, all these 192.168 networks all match. So we're going to do that. Network 192.168.0.0. Now what you want to do on this part, rather than doing the 255.255.0.0 that we did with static routing, we're going to use what's called the wildcard mask, which is the complete opposite. So instead of 255, we're going to do 0 dot. Instead of 255, we're going to do 0 dot, and instead of 0, we're going to do 255.255. Then you're going to give it an area. We're going to call this whole area 0. All these routers. Area 0. After that, we're going to give it just a minute, and it should start setting up Ospf. Hopefully give you a visual clue. I'm going to move on to the next router. Do the same over here. So config term, then we're going to go into router Ospf1. We're going to give it the router ID. It should be on this one, 2.2.2.2. Then we're going to do the network, which is 192.168.0.0, 0.0.0.255.255 for the wildcard. And we're going to continue to keep the area 0 on all these routers. And as you can see on that time, this is the OSPF. It's going through its process. It's letting us know when it's done. What happens is this router starts communicating with this router to figure out what all its interfaces are, what all its IP addresses, everything. So that is OSPF starting to build its table. So moving on to the next router. Going to continue on, do the same thing. So just like that, config term router OSPF1. Give it a router ID of 2.2.2.2 and set up the network and the wildcard mask as well as the area. Now it's starting to do its communicating. This is router 3, yes. Moving on over to router 4 and continuing the process. Term router OSPF1 network 192.168.0.0, 0.0.255.255 for the wildcard mask with area of 0. All these routers are starting to communicate with each other. Router 1, there it is. So this router now has everything on it loaded into its OSPF. And we can get back out. You can see on that one, I actually forgot to do the router ID, which is okay. You can still do it. We're just going to have to go right back into the OSPF mode here. Now we can do the router ID. And you can see it's going to make it a little bit different on this part though, but it is 4.4.4.4. Now, so what it wants to do in order to adjust the router ID in the OSPF process is we have to clear what is on there so that it rewrites everything. So we're just going to do a copy and paste on this clear IP OSPF process. And we're actually going to go back to the enable mode and paste that one in. It wants to verify that we do want to reset the process. We do yes. What that did is it put it in a down state momentarily in order for the interface to come back up. And now it's okay. See, now it knows the new ID I gave it. So go up here to the final router. Router 5. Config term router OSPF1. Go ahead and make sure we do the router ID first, 5.5.5.5, and then the network 192.168.0.0, 0.0.255.255, area of 0. Now OSPF is starting its processes. There we go. And it is all done. So right now, I have it kind of in an unusual lock state, but if I remember right, Control-Shift-6 gets in it to board it out. So now we're good. Let's go back over to router 1 here and kind of take a look at what we did. I'm going to go in and do it. Show IP route, which will give me the routing table. Now, as you can see on here by your codes going down through here, S is for static. And looking through here, this router has no static routes. And an O right here stands for OSPF. So you can see it has an O to that network. And that's how it's getting there. An O for that one. As you can see, it knows all the connected networks, the connected routes to get through this whole area that we labeled as 1 or 0. The area is 0. So you can see this number here, that 110. That is your administrative distance. And the lower that number goes, when it comes to routing, displays what goes first, meaning the lower number. Static is a lower number than 110, and that's why we had to delete it. I believe static routes, local and connected are first, then static, and it just keeps going down the list. So that's that. What we're going to do, just going to test the network real quick. Do a ping. Just in the ping over to 192.168.50.2. That'll be, put it over here. Remember, we're over here right now. And it was a success. So it was able to route using OSPF. What we're going to do is we're actually going to go into simulation mode, which is kind of nice in Packet Tracer. Okay. Simulation mode is, it's going to pause. So I'm going to do just a couple pings, and then we're going to watch the packets move in real time. We're going to send this router over to this 192.168.50.2. We're going to jump over here on this router, on router 4, and we're going to send a ping over to router 1. The great thing about OSPF is it load balances as well, so it will make sure traffic flows in the direction traffic needs to flow. We're going to jump over here to router 3, and we're going to ping this interface right here. And then we're going to turn on the simulation mode and see what OSPF does. Okay, gives us 3 pings, 3 routers going 3 different directions. Let's play and watch the packets go. And there they all go. They were sent, and they were received and sent back in the most efficient manner. And there you go. Everything sent, everything successful. Okay. And that is how OSPF works. So it is routing these packets that I was sending in the most efficient way. It's load balancing when it needs to, but it stands for open shortest path first. So it's going to look at the shortest path first, determine if that's the best path, and if not, it's going to route other directions. That's Thank you for your time. Enjoyed making yet another project troubleshooting video for you. Have a great day.